Hello everyone, Kotongwane, the Nated God here. Right, today I want us to look at resulting, also known as resultant velocity, which is under kinematics. Right, now when looking at problems or exercises based on resulting or resultant velocity for engineering science N4, right, what you need to take note of is that the resulting or resultant velocity is essentially, now before I go any further, this we refer to as VR, right, or we denote as VR. Now when looking at exercises related to resultant or resulting velocity for engineering science N4, right, we need to take note of the fact that VR is the vector sum of two velocities, right, and those two velocities will be VO, which is the original velocity, right, and VW, which will either be the velocity of the wind or the velocity of the water, right? Now, we get different scenarios, right, for resulting velocity, right? Like if you look here, the reason why we have velocity of the wind and velocity of the water is because it depends on the kind of scenario that you are looking at. For the most part, there's two scenarios that we normally look at under resultant velocity, right? That is either for an aircraft, right? One of the scenarios is based on an aircraft, right? And then the other scenario will be based on a boat or ship, right? Now, I just want us to look at how we denote the two velocities being VO and VW, how we denote them based on the kind of scenario that we're looking at. So, for instance, for an aircraft scenario, right, VO, right, will be either airspeed, right. So, if you're looking at a scenario based on an aircraft and they've given you the airspeed, right. If they've given you the airspeed, then you take the airspeed as your VO, right. But what is most important about VO for an aircraft scenario is that VO is actually the velocity of the aircraft relative to the air, right? So if you've been given, so for instance, if they haven't necessarily called a VO speed, but you are given a velocity of the aircraft relative to the air, right, then you take that velocity as your VO, right? However, that velocity is given as long as they've made a relation to the air, right, for that velocity, then you take it as VO, right? Like for instance, they could say the aircraft flies at whatever speed, right, in still air, right? So when they say in still air, it means that the velocity that they've given you is relative to still air or is relative to the air. Hence, you take that velocity as your VO, right? And then for a boat scenario, right? For a boat scenario, VO will be that velocity that is relative to the water, right? And then as far as VW, right? For an aircraft scenario, VW, right, will be the velocity of the wind. And then for a boat scenario or a ship scenario, VW will be the velocity of the water, right? And then of course VR, that is your resulting or resultant velocity, right, or the velocity. So essentially VR, right, the resulting or resultant velocity will be the velocity of the object, right, depending on which scenario you're looking at, be it you're looking at an aircraft scenario or boat scenario, right. The resulting or resultant velocity will be the velocity of that object relative to the ground, right. So if you've been given a velocity that is relative to the ground, or you've been asked to calculate a velocity relative to the ground, then you should know that it relates to the resultant or resulting velocity, right. Right, remember when we started, I said The resulting or resultant velocity is the vector sum of two velocities, those velocities being VO and VW, right? And I've just explained how you interpret VO based on the scenario you are given, also how you interpret VW based on the scenario that you are given, right? What is most important here is realizing that for resulting or resultant velocity, you always, so when you look at any problems or exercises related to resulting or resultant velocity, right, you always have to look out for three velocities. That's VO, VW, and VR, right? When looking at an exercise based on resulting or resultant velocity, right, you have to establish from the problem statements if you've been given any of these three velocities. The three velocities being VO, VW, and VR. Right? Right. Now, it is also important that you take note of the following. Right? The direction of the wind. Right? It is important that you are able to interpret the direction of the wind. Right? So I'm going to explain how you interpret the direction of the wind based on how it is given. Right? There is three ways in which the wind direction can be given. Right? So obviously this only applies to an aircraft scenario, because it's only with an aircraft scenario where we look at VW as the velocity of the wind, right? So I just want to explain the three ways in which the wind direction can be given and how you interpret that wind direction, right, based on how it is given, right? Now, the first scenario is when the wind direction is given as where it is coming from, right? You draw it in a direction that is opposite what is given, right? So again, for this scenario, right, I'm saying that if the wind direction is given from the perspective of where the wind direction is coming from, right, when drawing the wind vector on the Cartesian plane, you draw it in a direction that is opposite the one that is given, right? We are going to work out what I mean by this, right? What I mean by this, let us look at this problem statement, right? From this problem statement, we are only going to deal with the wind vector, right? And we are going to see how we interpret the wind vector if it is given from the perspective of where the wind is coming from, like I've explained in this scenario, right? Now, the problem statement reads as follows. A jet takes off at a speed of 380 kilometers per hour in the direction north, 32 degrees west. The plane is then blown off course by a 110 kilometers per hour wind from the direction west, 50 degrees south, right? Now, if you look at this wind vector, right, in terms of its direction, right, the direction is given from the perspective of where the wind is coming from, right? Now, as I've stated here, right, as I've stated here, that if the wind vector is given from the perspective of where the wind is coming from, then you have to draw it on the Cartesian plane in a direction that is opposite what is given, right? So that is to say, for instance here, the wind is coming from the direction west, 50 degrees south. So because the wind direction is given from the perspective of where the wind is coming from, it means we have to get the opposite direction of this, right? So if the wind is coming from this direction, it means it is headed in a direction that is opposite this one. It's coming from west 50 south. That means it is going in a direction opposite this one, right? Opposite of west 50 degrees south, right? Opposite of west 50 degrees south. So the given direction is west 50 degrees south. But because they said it is coming from this direction, it means it is headed, right, that in a direction that is opposite this one. Opposite of west is east. The angle remains the same, right? And then opposite of south is north. Excuse me, right? So because the wind is given from the direction of where it is coming from, it means it is headed in a direction that is opposite this one, right? For instance, if you were to draw a Cartesian plane, right, west 50 degrees south is in the third quadrant, right? So if the wind is coming from this direction, it means it is headed in the opposite direction, which is the first quadrant, right? And the first quadrant, right, has east and north, just like I stated here, right? So again, if the wind direction is given from the perspective of where the wind is coming from, you have to draw it on the Cartesian plane in a direction that is opposite the one that's been given. All right, that's one of the ways in which the wind direction can be given, right? And this is how you interpret the wind direction, right? Again, if it is given from the direction of where it is coming from, then you have to use the direction that is opposite the one you've been given. Why? Like I said here, right, that's your Cartesian plane, right? West, south is in this quadrant, right? If it is coming from here, right, if it is coming from here, it means it is headed in this direction. And as you know, right, we do not draw vectors on the Cartesian plane such that they are headed towards the point of intersection, right? Instead, we do that, right? So if it is coming from this direction, it means it is headed in this direction. Hence, me saying if your wind vector is given from the perspective of where the wind is coming from, you have to draw it in a direction that is opposite the one that's been given, right? Opposite of this is that. Opposite of west 50 degrees south is east 50 degrees north, right? Right, so that's just one of the ways in which wind direction can be given. Another one is this one here, where the wind direction is given from the perspective of where the wind is headed in, right? So I said here, when wind direction is given as the direction it is headed in, draw it in a direction that is the same as what is given, right? So that is to say that if your wind direction is in the problem statement is given from the perspective of where the wind is headed, right? So you use the wind direction that is given, or you use the wind direction exactly as it is given, right? By that we mean, let's just look at this problem statement. An aeroplane flies to its destination 300 kilometers directly east of its starting point. The pilot wants to complete the flight in 50 minutes. A wind blows in a northeastern direction at 10 meters per second, right? Now remember here, we're looking at the wind from the perspective of its direction, right? They said here, a wind blows in a northeastern direction, right? So here, they've given us the direction of the wind from the perspective of where it is headed. So the wind is headed in a northeastern direction, right? So because in this scenario, they've given the wind vector from the perspective of where it is headed. That is why you use the direction that is given as it is, right? If they say, for instance, the wind is headed in a northeastern direction, it's headed in a northeastern direction, right? As you can see, the vector is heading away from the point of intersection, right? That is why you use it exactly as it is, right? So that is to say, so here they said a wind blows in a northeastern direction, right? Northeastern direction is northeast, right? Northeast is in the middle, right? Northeast is in the middle of this quadrant, the first quadrant, right? So if it's in the middle of the first quadrant, it means that it is at 45 degrees from either of these axes. So 45 degrees from the x-axis, 45 degrees from the y-axis, right? So northeastern direction is the same as northeast, northeast, right? Because we work with angles, right? So we have to take the angle into consideration, right? Right. This means that this is at the center of this quadrant, and if it is at the center of this quadrant, that means the angle is 45 degrees east, right? And then when drawing the wind vector on the Cartesian plane, right, you are going to draw it in the same direction. Why? Because the wind vector has the wind direction has been given from the perspective of where it is headed, right? So that is to say, if the wind vector has been given from the perspective of the direction it is going in, then you use the wind direction that is given exactly as it is, right? So that's the second scenario. Now the third scenario, right? The third scenario is when the wind vector, what is when the wind direction is essentially ambiguous, right? By ambiguous, I mean it is unclear. So they neither say they neither say that the wind is coming from the given direction, nor say it is headed in that direction. Hence here I said when wind direction is neither given as where it is coming from or where it is headed in, then it is perceived as coming from the given direction, right? Excuse me. Now that is to say that if your wind direction, right, is ambiguous, so they haven't quite made it clear if the given direction of the wind is coming from that direction or heading in that direction, then you perceive that wind direction as coming from the given direction. Right? As coming from the given direction. Right? Let's look at an example. Right? Using this problem statement, it reads as follows: a jet plane flies and covers a displacement of 290 kilometers, while a southwesterly wind of 87 kilometers per hour blows it off course. Right? Now they say here a jet plane flies and covers a displacement of 290 kilometers, while a southwesterly wind of 87 kilometers per hour blows it off course. Right? Now, if you look at how the wind direction is given, right, they neither said it is coming from a southwesterly direction, neither did they say that it is going in a southwesterly direction. Right? That is what I mean by ambiguous. It is unclear if the wind vector is coming from this direction or going in this direction. Right? So because it is unclear, then you must perceive this direction, right, as if it is coming from, right, as if the wind vector is coming from this direction, right? So if it is coming from this direction, it means, just like the first scenario, it means you must draw the wind vector in a direction that is opposite the one you've been given, right? So because this is ambiguous, right, we perceive it as if the wind is coming from this direction, and because the wind vector is coming from southwest, right, southwest, right, southwest is in the third quadrant, right, southwest is in the third quadrant. So if it is coming from this direction, it means it is headed, right, it is headed in this direction, and because it is headed in this direction, that is why you must draw it in a direction that is opposite the one that is given, right? Now southwest, right, is at the center of this quadrant, meaning that southwest is 45 degrees from either of the axes, right? So meaning southwest is the same as south 45 degrees west, right? But because remember, right, we perceive this as coming from this direction, it means it is headed in a direction opposite the one that's given. Opposite of south is east, 45 degrees. Opposite of west, no man, opposite of south is north, 45 degrees. Opposite of west is east, right? Which is exactly what we have here, right? So in drawing the wind vector, right, you would draw it in a direction that is essentially north, 45 degrees east, right? And that is how you perceive the wind direction, right? Very important, right? It is very important that you understand this part of the wind direction, or how we perceive wind direction, or how we interpret wind direction, right? Because how you interpret wind direction will either make or break you, right? So take note of that, right? In the next video, we are going to look at this example first. We're going to look at this exercise, right? And then we're going to look at the exercise and look at this one as well, right? Just so you have a few scenarios, in which I take you through how we solve problems based on resultant or resulting velocity, right? Now, if you haven't subscribed to the channel, make sure you subscribe and also turn on the notification bell so you don't miss any one of those videos, right? Right. Trust this was helpful to you. Right. See you on the next one.